Hi guys! I am going to try and help you guys with the Weber's model. So let's go ahead and get started. I hope you guys are doing really well. I miss you. All right, so here's the thing. When you're looking at Weber's model, first thing you want to do is you want to make sure that you kind of make a little dot on each of the points. So where it says 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 11, 12, just because it helps you visually. So what you do is you look at the material quantities and transport rates. So if you see R1, which is raw material 1, for every mile it costs $5 per ton to ship. Well, there's 6 tons in raw material 1. So to transport raw material 1 mile, it's 6 tons times 5. So mile 1, you write in $30. For mile 2, all you're going to do is double that. So 60, mile 3, 90, mile 4, 120, and mile 5, 150. For R2, you're going to do the exact same thing. So without even looking at this, you're really not even looking at the model right now. You're just doing this for the transportation costs because you can't fill in chart number 2 without completing chart number 1. So same thing, raw material 2, it's 7 tons. It costs $5 per ton per mile to ship. So 35, 70, 105, 140, 175, and you guessed it, same thing with the market. 10 tons, $7 per ton per mile, so 70, 140, 210, 280, and 350. Now, what you're going to do is you're going to use these mile costs in order to get your total transportation for each proposed plant site. And your goal is, of these 12 sites, to find the least expensive, of course, if that's what you're going for. And we'll talk about other options in just a minute. So to find site 1, here's number 1 right here. In order to get your cost from each one of these locations, you need to count the rings away. So for site 1, it's only 1 mile, because each of these denotes a mile. It's only 1 mile from the material, so that cost is $30. For R2, it's 1, 2, 3, 4, 5 miles away, so that's $175. And then you're going to do the same thing for the market. You're going to count the rings, again, the rings away, so 1, 2, 3, 4. Okay, and that's 280. And you're going to add that all up together, and it's going to be 485. So what you do is you continue to do that for each site. So for example, site 2 right here is 2 miles away from raw material 1, so that's $60. From raw material 2, it's 1, 2, 3, 4, 5, so 175. And then from the market, it's only 1, 2, 3. So then from the market, we see mile 3, and that's 210. You add those up together, and that equals 445. So you do that through each column, and at the end, if you're looking for the cheapest location, well, you'll star whichever location is the cheapest, and you'll have arrived at that decision from looking at your transportation costs. But remember, it's not always necessarily about what's the cheapest to transport in the sense of the overall location. For example, some of your products, as you well know by now, could be heavier to begin with. And so if you have a product that is heavier, like let's say raw material 1 is the steel that's made to use cars, and raw material 2 is the leather for the seats. Well, it'd probably be smarter to be located closer to raw material 1 because it's heavier and it costs more to transport. But then you also have to take into account the market, and for example, cars, it's much cheaper to have the completed car closer to the market. So in that case, you might want to move closer. The whole purpose of Weber's theory is to put into play your variables and decide which is the cheapest location. And of course, what you know from your industry unit, that's the best way to make money. So I hope that made sense, and I hope you guys all do really well on your AP exam. I miss you, and if you need any help, you guys know you can email me, call me, Facebook me, whatever. All right? Bye.